with 100% certainty that the body is in equilibrium. So to prove that a body is in equilibrium, we need to satisfy these two conditions. There should be no net moment and the net resultant is 0. Few things you have to keep in
Sir,
mind. Yes.
the net moment can be about any inertial point, no? Outside or
Yes.
inside point.
Yes. Yes. Yes.
Yes.
If you are able to prove these two conditions, then your body is in equilibrium. Keep in mind two things. One, in this topic, we are assuming that all the forces are applied on one plane. So all the reactions are also on that plane. So we are only looking at two-dimensional problems. And we are only looking for static equilibrium. There is no dynamic equilibrium. Okay, static equilibrium meaning the body is not moving. So this was perhaps the slide where there were most amount of doubts. The first set of equilibrium equations said summation fx is 0, summation fy is 0, and summation of moment about a point is 0. That is straightforward. Everybody understands. Now, there were many questions asking why it is okay to take moment about any 2 points and summation fx is 0. And what is the reason behind this special clause that we have put? Why should line AB be parallel to y-axis? So let us try to prove this. Okay. Now, let us. So imagine that you have a body. So please ignore this. Okay. Please ignore this. Okay. Now, let us imagine that you have a body which is subjected to forces F1, F2, F3. Or please give me 1 minute. I'm stopping the share. I think this will lead to problem. Please give me 1 minute. Okay. I am deleting all the annotations.
Okay, sir.
Sir, in the PDF that you will share, will the annotations be available also?
No. In the recording, it will be there.
Okay, sir.
Now I think it is okay. So share desktop. Is the presentation visible?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
Okay. So now we were trying to find a proof as to why even these three sets of equation guarantee equilibrium and what is the thinking behind this special condition that we have employed. Okay. To understand that, imagine that you have a body which is subjected to several forces F1, F2, dot, 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 Fn. Now, let us say that there exists a point A where summation ma is equal to 0. So there exists a point A. If you take the moment about that point, then the net moment is 0. For this case, the body might or might not be in equilibrium because R can be non-zero. If R is passing through point A, if the R resultant is passing through A, R can be non-zero and this condition can still be satisfied. Yes?
Yes, sir.
Yes, sir.
Now let us add another condition. Let us say that summation fx is 0. Now if moment about a point A is 0, summation fx is 0, R can still be non-zero if R is perpendicular to the x-axis. So we have two conditions. Moment about a point A is 0, summation fx is 0. My resultant still might or might not be 0. We cannot guarantee that. There can be a situation where R resultant R is passing through point A and is parallel to the y-axis. Now let us add a third condition. Let us say that summation about point B is also 0. If the point B is lying on the y-axis, then we can have these three conditions being satisfied and the resultant still might or might not be 0 because the resultant could pass through points AB and also be perpendicular to the x-axis. So it has no x component. So these three conditions are satisfied, but my body might or might not be in the state of equilibrium. Yes? Now,
Yes.
what happens if AB is not parallel to the y-axis? And we have the three conditions: summation fx is 0, moment about point A is 0, moment about point B is 0. In that case, the resultant R has to pass through AB. But we have already said
Yes.
summation fx is 0. So this force cannot have any x component. If this resultant force does not have any x component, that means that the resultant R is 0. Therefore, we can say if moment about 2 points, let us say A and B is 0, summation fx is 0, then my body is guaranteed to be in equilibrium if AB is not parallel to the y-axis. Is this clear?
Yes,
Sir,
sir. Now it's clear.
Yes,
sir,
sir.
sir, can you
Yes,
repeat
sir.
again?
Yes, sir. Clear.
No, sir.
No. So I'm hearing a few no. So let us study again, okay? So let us imagine that you have a body. Let us say you have a body which is subjected to several forces and moments, F1, F2, dot, dot, dot. Now, we found out a point A such that the sum of moment about A is 0. Now, in this case, the resultant R might or might not be 0. If R passes through A, even then this condition is satisfied. Yes? Now,
Yes,
let's
sir.
introduce a
Yes,
second
sir.
condition. Let us say that
Yes, sir.
summation of forces about X is 0. If summation of forces about X is 0, R might or might not be 0 because we can have a condition that R is passing through A and is parallel to the y-axis. So these two
Yes.
conditions, MA is 0, Fx is 0, does not guarantee that my body is
Excuse
in a
me,
state
sir.
of equilibrium. Yes?
Are we dealing in two dimensions only in this
Yes.
question?
Yes.
Okay, okay.
Now we have a third condition. Let us say that the summation about point B is 0. If point B is lying on the y-axis like this, even then our body is not guaranteed to be in a state of equilibrium because I can have a resultant which is passing through AB and parallel to the y-axis. So my three conditions are set. Now if I have a point B
Sir,
was
your
not
voice is not audible.
hello,
Sir, it was cut in between.
now it's okay.
Your voice.
Yes, sir. Now
Yes,
it's
Yes,
sir.
fine.
sir.
Yes, sir. No, it's okay,
Oh,
sir.
Yes, sir.
okay.
Just last 2 seconds you are not audible, sir.
Achha. Maybe
Yes,
1
sir.
minute. Yeah, okay. So better, no? Hello,
Yes, sir.
can you
Now
hear
it's
me?
yes,
Okay.
sir.
Yes,
Yes,
sir.
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Now let us imagine that the B is not parallel to y-axis. If moment about A and moment about B is 0, then the resultant has to pass through the line AB. But we also said Fx is 0. Now, if Fx is 0, it means that this force has no x component. This resultant has no x component. That can only happen if
the force
resultant
itself is 0.
itself is 0. So, if summation of moment about point A is 0, moment about point B is 0, and if summation Fx is 0, then the body is guaranteed to be in a state of equilibrium. Now, if you have understood this, try to answer this question. Let us say I want to use summation Fy is 0, summation about moment point A is 0, point B is 0, then what condition must AB satisfy? That what condition must the line AB satisfy to guarantee equilibrium?
AB must not be parallel to the
AB not
x-axis.
parallel to y.
AB must not be
Sorry, AB
parallel
not
to
perpendicular
y-axis.
to y.
AB not
AB must
perpendicular to
not
Y.
parallel to x-axis.
Correct, exactly. So,
Excuse me, sir.
yes,
Sir, the y-axis in this case is our choice, no? Means
yes.
we can. So then we can adjust y-axis anyway, no? Then how?
But you can take any XY coordinate axis system that you like. You can take any points AB, but AB line should not pass through the y-axis, which you have chosen. And while doing summation fx is 0, you have to be careful of the axis coordinate axis system that you have chosen.
Okay, sir.
Sir,
Hello, sir.
Yes.
Sir, if the body is in equilibrium, then Fx as well as Fy should be zero, no?
Yes. but we are looking for 3 equations which guarantee equilibrium. There
Then in
can
the
be more
point
than
B-
3 equations, but there will be linear combinations of each other. You have to look for one set of 3 equations. The first set could be summation fx is 0, fy is 0, moment about a point is 0. These are 3 equations. This
Sir,
is one set. The
sir,
other set,
if AB is parallel to y-axis, then the equation of MA and MB would be same, sir. If we consider fx equal to 0, the equation of MA MB would be same, and we would not get the 3 equations.
exactly, that's what we are trying to say.
Sir,
Yes.
if we prove that moment about point A and point B is equal to 0, does that suggest that moment about any point would be 0?
No. Moment
Then we can say
about any point will be 0 if it is in a state of equilibrium.
so if we are finding a condition for equilibrium and proving that about these 2 points is 0, does it implies that the body is in equilibrium?
No, you need 3 conditions. MA is 0, MB is 0 are 2 conditions. The third condition, summation fx is 0 is needed to confirm static equilibrium.
So in case when we find that moment about 3 points is 0, then that is sufficient condition.
Correct. That is my next.
So
That is the
it would
next thing
suggest
that I want to explain.
if we take any other point D, then moment about D will also be 0.
Yes.
Okay.
Okay. So the second variant of our equilibrium equation was when we said summation MA is 0, MB is 0, and MC is 0. Now, what is the reason behind this? How can this justify equilibrium, and why do we have this condition that MA is 0, MB is 0, MC is 0 will guarantee equilibrium if and only if A, B, and C do not lie on a single line? Let us try to prove this. Okay. Let us consider the same body. It is subjected to many forces. The general case F1, F2, dot, 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 Fn. Let us say summation of moment A is 0, summation about point B is 0. If these 2 conditions are satisfied, my body might or might not be in equilibrium because the resultant could pass through point A and B. Here I am not making any judgment about the coordinate axis system. I have a system, it is subjected to many forces. Moment about any 2 points I have found out it is 0. Let us say those points are A and B. This does not guarantee that my body is in equilibrium because I could have a resultant force which is passing through points A and B. Now, what happens if I choose a third point? Let us say that third point is C prime. Now, summation MB is 0, summation MA is 0, summation MC prime is 0. If this was the case, my body might or might not be in equilibrium because R could pass through lines ABC, if ABC prime, if ABC prime were collinear. Now, if my condition is that summation MC is equal to 0, ABC is not collinear. Now, the resultant has to simultaneously pass through AB and BC, which is not possible if they are not collinear. So, the only condition left is R has to be 0. Therefore, we can say if moment about 3 independent points A, B, and C, the summation is individually 0 and A, B, C are not collinear, then net moment is 0 by definition, and the resultant R is also necessarily 0. Therefore, my body is guaranteed to be in a state of equilibrium even if I am able to prove this. Okay?
Yes, sir. Clear.
Yes, sir.
Sir, can you explain once again?
You want me to repeat this again?
Yes, sir, the proof.
Yes, sir. I also know.
Starting from here, is it?
Yes, sir.
Yes, sir, the proof, sir, the proof.
Okay, okay. So let us consider a body which is subjected to a general loading. There is F1, F2, dot, 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 Fn. There are moments. Now, let us imagine a 1 minute. Now, let us imagine that summation of moment about point B is 0, summation of moment about point A is 0. If these two conditions are there, my body might or might not be in a state of equilibrium, because I can have a non-zero resultant R which is passing through points A and B. If a non-zero resultant is passing through points A and B, this condition is still satisfied. Both of these conditions is satisfied and R might or might not be zero. So let us introduce a third condition. Let us say that summation about a point C prime is zero. Now two things can happen. C prime could be in the same line as AB, or C could be non-collinear to AB. If C was collinear to AB, then the three conditions, moment about point A, moment about point B, moment about point C is zero, and resultant is non-zero, because resultant R could pass through ABC. However, if AB and BC are not collinear, then what can we say? Then the resultant R has to be zero, because it cannot simultaneously pass through line BC and AB. A resultant force can have only one direction. The only now condition that we have is R has to be zero. So if net moment is zero and these three and the resultant R is zero, my body is in equilibrium. Okay?
Yes, sir. Yes, sir.
Anybody has any
Yes.
doubts?
No, sir.
So
No, sir.
basically,
Got it.
so basically, the logic is that you can use any one of the 3 or 4 equations of equilibrium. All of them will lead to the same answer. Your solution is unique, but the way you draft your equations is up to you. You could do moment about any point that you like. Summation fx is 0, summation fy is 0. Or you can say that I want to take moment about 2 points and summation of forces in a certain direction. That is also okay. And another point is, you could say, no, I want to take moment about 3 points. All 3 of them are fine. All 3 of them will ultimately lead to the same equation, because all these equations are interdependent on each other. You can choose any one set of equilibrium equation that you like to solve your problems. Okay?
Yes,
Can
sir.
I go to the
Yes,
next
sir.
Yes, sir.
topic?
Yes, sir.
Yes, sir.
Thank you. Thank you. Thank you. So the next topic was about the free body diagram and how it is drawn. So I'm taking the example of a roller support. When you draw a free body diagram, you should not look at what the applied load is. Okay, keep few things in mind. When you draw a free body diagram, just focus on the constraint and try to imagine what degree of freedom is this constraint allowing, what degree of freedom it is blocking. Do not think about the load, whether it causes that movement or not. You should just focus on the constraint. This is point number 1. Point number 2 you should keep in mind is, in engineering applications, unless otherwise specified, you have to neglect the mass. For most applications, the mass of the body is significantly lower than the load it is going to encounter. So that for a large number of engineering applications, we neglect the mass. Point number 3 you need to keep in mind, unless otherwise specified, friction is ignored. So if friction is important, it will be clearly be written that friction is there or surface is rough, something will be given. And unless otherwise specified, you will ignore the mass. So now let us try to draw the free body diagram of this member. Keep in mind that this member is part of a bigger member. I am just trying to draw the free body diagram at the end where roller support is there. And depending on the book, depending on where you look at the problems, all of this describe the same roller support. All of this mean the same thing. All of these are schematic representation. A real roller might or might not look like this. Now, if you have a system like this, my body is allowed to rotate. The roller has no problem if it wants to rotate. A roller also allows horizontal movement. The roller does not allow vertical movement. So when you draw the free body diagram of this, it is only going to have a reaction in the vertical direction, in the direction where movement is constant. This is the free body diagram, irrespective of the load that is applied. Another important thing to keep in mind is the direction. When you are drawing a free body diagram, please do not worry about the direction of Fy. It could be going upwards or it could be going downwards. Unless friction is important, you should just draw whatever you like. It could be upwards, it could be downwards. If your sense is right, your magnitude will be positive. If your sense is wrong, your magnitude will be negative. It does not matter. Do not try to look at the load and try to calculate or try to imagine what the direction of the reaction force will be. You can just assume a direction. So Fy pointing upwards is also right. Fy pointing downwards would also be the correct free body diagram. Okay. Any questions about this?
So we are
Sir,
basically replacing
excuse
the
me, sir.
constraint uh, with the reactions in order to just leave the trace on the free body
Yes,
diagram that
exactly,
the
exactly. We are trying to quote unquote free the body. How do you free the body? You free the body by removing all constraints. And wherever there is a constraint, you have to put a reaction.
Yes,
Sir, how can this roller support means force can act in vertical if it is not able to move in vertical direction? Means that I could
That is the reaction. Na? Reaction happens if a constraint does not allow movement in some direction.
Sir,
yes,
Sir,
sir.
I have a doubt in
Sir.
total equilibrium part 1.
Yeah, tell me.
Can you please show the slide number 14?
Let us do something. I think I have planned something depending on the frequency of the doubts that were asked. Your exact doubt we will consider during our tutorials tomorrow. Does that work?
Yes.
Actually, sir, I need to get a clarification in the slide.
Okay. 1 minute. Let me open. Which slide?
Slide number 14.
1 for 14?
1 4, sir.
Okay. Yes, is it visible?
Yes, sir.
Tell me.
Sir, in that it is given in a very general case, two forces pass through a point. The third force may not be concurrent, and in that box, it is given that three forces must be concurrent.
Yes. So imagine that two forces are passing through point A. Okay, in a general case, two forces will pass through point A. The third force might or might not pass. Now let us take moment about point A. For equilibrium, summation Fa must be equal to 0. Summation Ma is equal to 0. F1 is passing through A, F2 is passing through A, it does not contribute. F3 is only contributing to Ma. Ma is equal to AD cross F3 is equal to 0. Now, either AD is 0, that means it is concurrent, or F3 is 0. If F3 is 0, my body is not subjected to three forces, but only two forces. So the only condition left is AD is 0. So if I have three forces, then my body must be concurrent. Okay?
Sir, in this
Can
case,
you repeat once again?
Okay. So basically, I am saying that let us say two forces are passing through A, one is not passing. Let us take moment about point A. Summation Ma is equal to 0 for equilibrium. Now F2 is passing through A, F1 is passing through A. So moment of point about point A is F3 into AD or AD cross F3. Now F3 cross AD is equal to MA is equal to 0 for equilibrium. If AD cross F3 is 0, that can only happen either if F3 is 0 or AD is 0. F3 cannot be 0 because we have said that our body is subjected to three forces. The only condition is AD is 0. So F3 also has to pass through point A for equilibrium.
Okay, sir, got it. Thank you.
Yes,
Excuse me, sir. Sir,
Yes.
in the roller support slide, the roller support is exerting reaction force in the positive y direction. Is it due to the internal forces developed in the rollers, means in the body?
No, I just said, na, when you draw the reaction forces, don't worry whether it is pointing upwards or downwards. You know the direction, but you do not. So if this was right, the magnitude would be positive. If this is wrong, the magnitude would be negative. You
No,
do
no,
not.
not about direction, but what is the cause of the reaction force?
The cause of the reaction force is the fact that it is a constraint. Whenever there is a constraint, when does reaction happen? In real life, let us say you are at your home, you want to do whatever you like to do. Will you react? No, you will not react. But let us say you want to go out and